One important topic as we get into how this all works is the topic of vSphere namespaces. So if you're familiar with Kubernetes, Kubernetes provides this construct of a namespace that allows for resource isolation, right? And so it can use things to provide like quotas for how much capacity that a pod can utilize on the host, and what it provides a security boundary mostly around that host level, because in containerized environments you've got several different containers that get orchestrated onto a common host, and you may want to have some security isolation as well about what the relevant containers are able to access on that host. And so namespaces in Kubernetes provide that type of isolation. And so it would make sense, right, that as we do things like enable the Supervisor Cluster, which installs the Spherelet on the ESXi host, which enable ESX and vSphere to really natively understand Kubernetes constructs, that these constructs of namespaces also apply, but at this deeper layer integrated with vSphere itself, and that allows for some very powerful constructs for workload management, which we'll explore over the next couple slides. Okay, so each namespace has its own resource pool. Right, so you have the resource isolation quotas, and so we can see an example of this on the screen here, where we have things like CPU, memory, storage policies, configurable through the familiar vSphere client interface. And so we see here, since we have Kubernetes in the hypervisor layer, and we can create things like TKG clusters that are provisioned on top of that layer, you can provision all of these assets that are provisionable through the supervisor cluster into a namespace. You can allocate for a particular tenant one of these namespaces with an associated security and resource allocations that provide boundaries for what the tenant is the amount of capacity the tenant's able to use. So, and here's an example of utilizing namespaces as a boundary for applications. And again, so generally modern applications are made up of a series of multiple distributed microservices, and oftentimes can consist again of serverless functions, of Kubernetes applications, of virtual machines, and this methodology that's vSphere 7 is capable of providing all those resources into a namespace is a powerful methodology for managing application resources, application consumption, security boundaries. Here we see a final build out of the previous architectural diagrams we've been working on to show some examples of what this looks like with applications running on top. And so again, Supervisor Cluster, think of it, it's just like an ESXi cluster, enabling an additional suite of services. Workloads will run. You can request things like, I need a Tanzu Kubernetes cluster, and the TKG service will work with OVA images that are prepared with the Kubernetes required software for running a Kubernetes cluster, right? And it'll orchestrate and automate the deployment of the Kubernetes cluster, and provide the methodology. The architecture is prepared, and the services are prepared to extend the login information and authentication services to the requester of that Kubernetes cluster. All of this works together to provide a range of self-service capabilities for how DevOps teams and developers prefer to interact with infrastructure, right, around Kubernetes. And Kubernetes itself and developer tool sets that are being optimized or that have already been optimized to work around Kubernetes environments use these type of constructs, right? These YAML Kubernetes manifests to be able to deploy resources. And so with the integration into vSphere, we can do things like deploy Tanzu Kubernetes clusters in a Kubernetes manifest, as well as standard pods, and also virtual machines, providing really a new a totally new way for developer self-service to be able to leverage the virtual machine environments in more highly automated and developer-friendly access methodologies. By bringing virtual machines into this Kubernetes construct, it provides an assurance that this is not only a methodology and a format that developer organizations are comfortable with. It is in the format that I think just the developer community at large has spoken that this is their preferred format. This is their preferred methodology for interacting with infrastructure. And as well as, again, additional custom resource types that we're able to deploy through the VMware Marketplace and leveraging the Kubernetes extensions. Okay, now as we get into Kubernetes networking, one of the core tenets of the Vsphere Tanzu architecture is the batteries included but swappable approach, and so Vsphere Tanzu includes complete enterprise-grade networking capabilities that also have multiple options, right? So options from using the standard vSphere distributed switch capabilities. We also support, we have support for open source solutions, as well as for NSX for customers who have NSX licensing. There's a whole level of additional and enhanced functionality capable through NSX integration. So for our networking and more specifically our container network interface for Kubernetes networking, there's a choice of Calico or Antrea container network interfaces, and Antrea is the Calico and Antrea are both open source, popular open source networking solutions with integrations and support for Kubernetes. Antrea is a new solution that is open source but backed by VMware, and it's really created by the same team that created Open vSwitch, which has really become a staple in the Linux community. And so Antrea is the default CNI plugin, and again also support for Calico as well. Now we'll take a deeper look at vSphere with Tanzu services. We'll look at how self-service management of Kubernetes clusters works for developers. And so in addition to having TKG APIs and a CLI interface, for vSphere with Tanzu also offers extensions for kubectl. For any developer or DevOps team that is working with Kubernetes, the kubectl syntax is really the most common tool, the standard CLI tool to interact with Kubernetes clusters. And so this puts us in a very familiar context. Use standard Kubernetes manifests, standard Kubernetes commands to be able to request services. And again, the administrator is able to define templates, so of sizes and policies that are available. So when a developer wants to request a cluster, there can be certain sizes, certain kinds available that are kind of pre-templated for the common types of Kubernetes cluster definitions that are needed in the organization. Okay, automatic load balancer provisioning. So one of the really powerful features of Kubernetes is that it has standard load balancing services integrated in the nature of how it works. And so whenever you prepare applications to work in containerized environments and go to deploy them in Kubernetes, it's the how do I automate load balancing? It's such a standard and simplified, optimized way that works for all the applications that run in the Kubernetes environment. And so, but when you are the platform operator for Kubernetes, you install Kubernetes on the infrastructure, you have to provide a load balancing service that has the adapters and is configured and integrated to support. So when a developer says they need to create an ingress service, when they need to access a load balancer service, for example, that the Kubernetes installation itself has the ability to fulfill those requests and provide those automated load balancer services. And so the vSphere with Tandoo includes the network service and the supervisor cluster that will fulfill these ingress and the ingress and load balancer requests to be able to provide those full-featured services to the developers and consumers of the Kubernetes environment. Now we'll look at the integration of the VMware vSphere Cloud Native Storage and vSAN. And so vSphere has had support for attaching volumes and providing storage services for Kubernetes and containerized workloads for several iterations now. And the newest is Cloud Native Storage. It's really native integration and native support for cloud native storage volumes. And so we get first class visibility and access to policies, access to tooling in vSphere. Anytime, in Kubernetes, when you request a volume to be attached, the volume that you attach to that container is the same exact volume from a vSphere perspective that you might attach to a virtual machine. So really enabling that vSphere admin to be able to, again, apply all their knowledge, all their skills very quickly and reliably support a robust storage service, and at the same time the developer having access to a rich array of capabilities that they can access through Kubernetes. And here we see an example, right? We can see here these on the left side of the upper diagram, like MySQL or Redis, are examples of applications that would request volume services from the underlying infrastructure provider. Cloud storage interface is the service, that definition that from the Kubernetes itself on how various underlying infrastructure providers can interact with to provide those storage services for Kubernetes. And under here we see the cloud native storage control plane is able to communicate directly with the cloud storage interface and provide a storage-based policy-based management for vSAN and vVolumes, VMFS and FS, and also file services to be available for requests through Kubernetes. Now, another, again, powerful construct here that really helps is on one side of this equation here, on the developer side, they're used to thinking in terms of Kubernetes, and they would prefer to interact with Kubernetes when they're examining their application deployment and maybe their DevOps practices, and at the same time, vSphere administrators who would support the underlying infrastructure need to be able to speak a common language. If a developer is looking at application performance and something with a volume, and they ask Kubernetes, they run a Kubernetes command, and Kubernetes gives them certain types of identifiers, and they contact the infrastructure team for support, they need to be able to communicate through the terms of Kubernetes and have the support person on the vSphere admin side be able to really understand and relate that to the underlying infrastructure objects and vSphere services that actually fulfill the requests for the volumes. And so you can see here, for example, that common language of how by looking at different views of the same objects here in the vSphere interface, we can find the Kubernetes identifiers in that language that the Kubernetes developers are more familiar with, and easily click in to see familiar vSphere administrator contents so they can use their expert skills in doing any troubleshooting needed to support delivering robust storage services. How does the developer use it? Okay, so let's look at how some of these roles apply, really break down to optimize workflows between DevOps organizations and underlying infrastructure and operation teams. Okay, so the key message here is we want to empower the devs, give them the flexibility and the freedom that they need to do what they need to do at the cadence they need to do it. At the same time, providing assurance that the organization, that the overall underlying infrastructure, which provides support for the whole company, not just one developer team, maintains absolute integrity and stability of the underlying infrastructure, and adheres to all of the regulatory and corporate business requirements that are required of applications running for the infrastructure. Okay, first let's look at for the vSphere admin. They are able to continue to use the familiar tooling of vSphere while we're introducing new constructs into vSphere. The way that vSphere is managed from the infrastructure administrator side, they're not the infrastructure admin is able to use those common tools for visibility, for troubleshooting, for support, for defining operational policies, right? While at the same time we're exposing new types of interfaces, primarily for DevOps users to be able to consume, allowing the vSphere admins to again to continue to leverage their experience, their training, support, get things up and running, and when they start deploying these brand new types of services, they're able to do it in method, bring things into production through the interfaces that they've been knowing and supporting for production grade enterprise operations for years. The Supervisor Cluster empowers those native Kubernetes interfaces and APIs to empower DevOps developers and DevOps teams to have a new developer self-service interfaces that we know are exactly the type of interfaces that developers have been asking for. Really, still in this stable footprint that provides the assurance to operators and the freedom to developers. Okay, so in summary for vSphere with Tanzu, really, it provides native integrated both Kubernetes services, but in an enterprise architecture that can automate and deliver the type of interfaces and the type of experience that we know developers want from infrastructure provider, and really empower the vSphere administrator to set the bar and really meet the demand to delight developers on how they can interact with infrastructure capabilities. At the same time, you're providing vSphere administrators with the assurance that they need. Okay, and so in this section, we'll review Tanzu mission control. The preferred method for operating Kubernetes clusters today is to run multiple Kubernetes clusters that are bounded around maybe things like application spaces or aligned with project teams for isolation reasons, for high availability reasons, right? If you have 20 different teams applications running in one cluster, and there's some fault in that cluster, you've got a challenge there, as well as running multiple namespaces have known limitations and known vulnerabilities, and so they really don't provide an adequate level of security for regulatory compliance, and the boundaries between clusters that are provided by virtual machines as well in vSphere environments can provide that required isolation between security zones. And so lots of different reasons to need. So for example, like you need to have different types of Kubernetes cluster. You've got test, you've got dev, and you've got prod, and you've got different types of application needs. Perhaps some may need GPU integration, some may have Windows containers, etc. Okay, and so the reality for adopting Kubernetes is that there's growing fragmentation, and so if you're able to adopt and implement solely on one particular platform, that at least gives you one interface to provide all the policies and all the configurations, to do all the security automation interfacing that you need to do, to get the logging and the metrics and analytics and all these different things you need to do to operate a Kubernetes runtime platform. However, running on one infrastructure provider is simply not a reality for most enterprises. There's various, in addition to things like Kubernetes runtime services, there's also just both from the largest cloud providers to more specialized providers. There's a whole host of software as a service providers that are providing attractive opportunities to business to say, hey, if your application that you are developing or service that you're providing, we can provide some component of that as a service, and it will be attractive for the business. And so really that comes down to a business decision, and a lot of businesses are deciding, hey, and business teams are deciding it's attractive for this particular application to build leveraging particular service that's available through Azure or Google platform, and there's a genuine business reason behind it. And so businesses are facing significant demand to be able to allow access in a way that provides governance and visibility and doesn't result in application teams accidentally violating regulatory compliance or leaving customer data out on the internet somewhere to be a news story. But being able to be able to allow to provide these types of services, if you have to go and craft security policies, access policies, configuration for each independent service and have expert teams to be able to do each one of those becomes, really incredibly cumbersome, if not, almost a non-starter because of the overall complexity and cost and endeavor to try to ensure that even with lots of resources that specialize in each area, that you're able to provide that consistent, common policy guidance and centralized visibility across all these environments. And as we know, increasing operational burden leads to increased risks. We know over and over again, studies have shown, that lots and lots and a large percentage of IT outages that create significant operational problems in organizations and bear great expense happen from user errors. And we know that this is compounded when you have a lot of primitive interfaces and you have 22 different clusters out there, and you have an admin that's going out and telnetting or SSHing into in each one of these independently and trying to eyeball it and make sure that they have the proper configuration. That methodology doesn't result in the ability to provide a stable, robust, and reliable service. You need to have interfaces that are capable of ensuring that centrally reporting and the health of the Kubernetes clusters in ways that actually do an appropriate health check. So that way the organization has constant assurance that the Kubernetes health is optimal, that the services are functioning, and in the event that something is not, that there's proactive notification to be able to handle those issues before they become a problem for the business. And this is, again, where Tanzu Mission Control comes in. So providing this centralized management platform, great view into seeing visibility for all your Kubernetes clusters and health, as well as the really elegant ability to deliver most of the common administrative needs and doing backup, setting policy, etc. And so we have productivity is a huge aspect here, right? You have developers that are coming on board. Some developers only have access to the dev tier. Some will need access to production tiers, and developers may be working on numerous different projects. And at minimum, projects each different projects will have different namespaces in the Kubernetes environment, and likely need to work across multiple different clusters. So maybe I'm supporting an application that it may be deployed to be available across multiple different sites. I may need to have access to clusters across multiple different sites to support that, but only subsections within those clusters. And I need to be able to carve those complex types of policies and align them with my organizational roles, right? Tanzu Mission Control, Identity Access, we'll go through this in a little more detail, but has really elegant mechanisms to allow you to create arbitrary groups of different namespaces across different clusters, and align those with your, say, Active Directory, or however you group your Open Identity, LDAP, etc., groupings, to be able to quickly align developers into a policy group that allows them to get immediate access to the complex variety of different assets that they may need to get to work quickly and be productive. We can see here an overview of several of the key functional areas of Tanzu Mission Control, from cluster lifecycle management and that ability to deploy and upgrade clusters, and identity and access, this ability for it to take all the clusters, whether it's a cluster that Tanzu Mission Control deployed, or whether it is a cluster that was deployed, really any Kubernetes cluster that's out and deployed and has connectivity to Tanzu Mission Control can be easily brought into management by Tanzu Mission Control and have its robust identity and access services applied. So you can have you can create groups of any namespaces, any combinations of namespaces and clusters that a developer or administrator may need that's aligned with their role, that can connect into your LDAP or Active Directory environments and quickly align your LDAP groups with the groups in Tanzu Mission Control that can instantly tie to a global fleet of distributed clusters to really ensure that your developers and administrators have access where they need in a very simple, centralized manner. Security compliance, there's a range of security policies that can be enforced globally across all provisioned and attached clusters, as well as the configuration and automated auditing services of the attached and managed clusters. Data protection, to be able to provide centralized administration over the backup, automation of backup runs, and including applying the policies to determine which objects you'd like to back up through Kubernetes and where you'll be backing them up to, and when and how those jobs will run. There is a good there is a good visibility into a health check and like the cluster overall health and availability in Tanzu Mission Control natively. However, to get into deeper observability metrics, deeper troubleshooting, deeper visibility, even application metrics as well, trend, etc. Tanzu Mission Control has integrations with Tanzu Observability by Wavefront. For application and service management, Tanzu Mission Control provides visibility into applications and Kubernetes objects, so the deployments and so on, and have integrations with Tanzu Application Catalog to facilitate application deployment and management. The Tanzu Mission Control has some of the native conformance inspection to ensure that the configuration of the cluster is in alignment with Kubernetes best practices, and that can be tuned by the organization to ensure that cluster configuration is in conformance with organizational policy compliance. And additional optimization services also will be provided through integration with VMware Cloud Health. And for connectivity and traffic management, Tanzu Mission Control's integration with Tanzu Service Mesh provides into the enhanced multi-cluster networking capabilities, networking and security capabilities provided by Tanzu Service Mesh. Here's a glimpse of the Tanzu Mission Control experience. This is a actual screenshot that I took of the cluster view, and we'll take a look at some of the larger interface here. But I wanted to show that here on one screen, the type of information that you can get in a very nice, very simple dashboard here. You can see I have clusters here from Azure, from Google Cloud, on vSphere, on AWS, and for each of them, it's running proactive health monitoring checks. They go through and verify the health of the service. It probes for key information and details like which versions of Kubernetes that are running, how many nodes I have running on each of these clusters, and the availability of resources on the clusters. And I can drill down into each of these clusters to get access to the full suite of information that Kubernetes provides about the cluster performance and availability. And so Tanzu Mission Control really has a very powerful central place that helps to provide kind of a common language and vehicle to have all the different constituents around a Kubernetes deployment, from infrastructure and operations team to DevOps and applications teams, IT management, et cetera, and to be able to get to leverage in an optimal way to optimize each of their roles, functions, operations is really the kind of the anchor behind it. However, the application team really needs to be able to have access, right, and to define the application policies. So a project manager for a project can help craft or define who should have access to what within the confines of their particular application project. IT managers may be thinking about things like what's the cost of this particular application or that application, and how can I control those costs by managing the resource allocations that are available and getting a proper fit of those resource allocations and how these are deployed. And finally, developers, right, are really thinking about, I just want the easiest way that I can to be able to get the infrastructure resources that I need to get my application rolled out. And so Tandoo Mission Controllers really provides just an important baseline that really enables each of these different groups of users and empowers them to have the type of Kubernetes experience that they desire, that makes them the most productive and efficient that they can. Okay, now let's look at some Tanzu mission control use cases. Okay, first, again, multi-cluster management. And so Tanzu mission control really allows you to define global policies across your Kubernetes environments that through a centralized common interface without needing, so you can deploy and you can manage and you can have centralized policies across all these environments through the common interface, even across multi-cloud and hybrid cloud environments. And if you have existing clusters, perhaps you have teams that have already running services on a cloud provider service that would like to have additional support or governance from a centralized IT organization. It's very simple to attach an existing cluster by installing some agents on an existing Kubernetes cluster, and any standard conformant Kubernetes cluster can be easily brought into this visibility and control from TMC. Managing Kubernetes on vSphere 7. And so Tandoo Mission Control provides has integration awareness with the Supervisor Cluster, and is able to help with the Tandoo Kubernetes, or to provision and provide automations and user interface for managing Tandoo Kubernetes grid workload clusters on vSphere 7. And so you can provision and attach TKG or attach TKG guest clusters. You can automate TKG attachment and the automated provisioning process. You can extend and connect the environment to the public cloud seamlessly. So again, reducing the operational burden and really simplifying the availability and manageability and service level of the Kubernetes service for the enterprise. Okay, now edge use cases in particular, you may have, depending on the size of your enterprise, if you're thinking about having some data centers where you want to deploy your application for availability, if you have a global footprint, you might have several global data centers. But in general, where we're talking edge use cases, we're talking about a substantially larger number of deployments, and very frequently these deployments are to unmanned locations. And so in the case of edge, while the benefits of the edge use cases are extremely attractive, it offers really substantial improvements on the overall life cycle and process of deploying application services to remote locations. However, it's really untenable without a solution that makes the multi-cluster management and control very effective and very efficient. And so let's look at the Tanzu Mission Control architecture. Our first layer, we see our lifecycle management and managed clusters. And so representing the ability to deploy and lifecycle manage the clusters themselves on AWS or vSphere Azure, or for any other environments, or if we want to deploy the cluster through some other means and then attach it to Tanzu Mission Control, then we have the ability to do apply the resource hierarchy. If you look at the layers above the cluster layer here, that kind of implies that the things that we have above here can be applied to either or. So once you have attached a cluster, you don't get to do the lifecycle management of a cluster that you've just attached. However, when it comes to identity and access management, attaching those clusters to allow the namespaces and the clusters themselves to be provisioned to these groups for easy identity and access management. As well as the policy engine, being able to apply security and network and image registry policies, namespace quotas, etc., to the entire fleet. And so while lifecycle management services themselves are limited to just the clusters that you choose to have Tanzu Mission Control deploy on those platforms, any cluster is able to still take advantage of really the majority of this functionality from available through Tanzu Mission Control. And so let's take a quick look at how the attachment process works. So for attaching existing clusters, so I could have some cluster over here, and generally the way that applications are deployed on Kubernetes is a provider will provide a manifest that will that can be deployed to Kubernetes that will automatically install the appropriate containers in the environment and namespaces and make the other configurations to allow that cluster to be monitored and integrated with Tanzu Mission Control. And so when you come to the Tanzu Mission Control interface and you say you want to attach a cluster, it gives that very standard Kubernetes manifest that you can just copy and you can paste, or you can hand to the administrator of that Kubernetes cluster to say, here, if you can apply this to the Kubernetes cluster, it'll allow the Tanzu Mission Control environment to have that visibility and to be able to provide all the services that it's capable of providing. Okay, now we think about, let's look at our resource hierarchy there with organizations, cluster groups, and workspaces. Hierarchy. At the top of our hierarchy, we have the organization. And within an organization, we have these constructs known as cluster groups and workspaces. And so first, let's look at the cluster groups. What is a cluster group? Well, a cluster group is a group of Kubernetes clusters. And it's a very, very flexible definition because an organization may have a need may deploy certain applications for a particular function, for a particular team, for a particular application, and may have clusters deployed at several different sites and need people to have certain access to combination. And those just may be a subset of an organization's overall volume of Kubernetes clusters. So organizations may have complex or do have complex needs, and so cluster groups are a highly flexible entity to make it simple to take clusters, to provide them into a grouping that can align with the roles and projects that exist, to make sure that different team members can get access to the clusters that they need to support their organization, their team, their project. So cluster groups are generally, cluster level access is generally associated with DevOps users or operational support users, whereas developers often will generally have access to namespaces. Every Kubernetes application gets deployed always in a namespace, and it's generally common for applications deployed in Kubernetes to create namespaces and to use namespaces as resource boundaries for different functions within an application, or keeping different applications within resource boundaries within a given Kubernetes cluster. And so developers will commonly have a need to connect to a variety of different namespaces across a variety of different clusters of different types and maybe in different locations. And so workspaces allows that flexibility to craft roles and groups where that can be really an arbitrary combination of any namespace they attach to Tanzu Mission Control. you can align with the workspace and align that with the identity and access control. So as for all the clusters that are under TMC management, you're able to align them with your Active Directory, your LDAP groups, what have you, to quickly align your workforce and your developer groups with the combination of access that they need across your global environment. Now, the policy layer. Now, I'm going to only go into limited a view of the policy layer. There's a wide range of policies, centralized global policies that can be crafted in Tanzu Mission Control. However, there are licensing limitations for Tanzu standard that only prevent the full use of all the capabilities at the policy layer. For example, there are, say, security policies that are provided, standard security provided at this layer in the Tanzu standard package. However, as you get into further customized policies, many of those aren't supported in some additional types of policies. And so we're not going to go through great detail on breaking down explicit details there. There is additional information about those breakdowns both on the website and in the Tanzu Advanced course that will be available, as well as through your VMware account team or through the partner team to get more detailed questions answered on the differences on what's licensed within for standard versus the advanced editions. For the purposes of this course, we're just going to look at a couple of the items, and the items that are included in the package at the time of recording are subject to change. I think it's probably going to stay very close to how it is now, but depending on how long this course is out there, it's always a best practice to confirm with the website and with your VMware account teams to ensure that you have the most latest, most relevant details. Okay, and so as we discussed before, one of the really key benefits of this policy layer, I think the largest right off the bat, which is supported through standard, is this ability to have our workspaces and cluster groups and to apply those policy vehicles through identity and access control, really to very quickly get developers and administrators access to the environments that they need to get up and running quickly. Okay, so we can see here a deeper dive into the Unified Identity and Access Policy. So VMware Cloud Services has a centralized service for providing identity services that the Tanzu Mission Control, Tanzu Mission Control is part of the overall VMware Cloud Services umbrella. And VMware Cloud Services so provides that centralized backend for configuring your identity, and so you can create accounts and so on directly through VMware Cloud Services Management, or have it point to OIDC providers, as well as integrate, federate with Active Directory, and so on, and then import those groups through Tanzu Mission Control, and then define the access policies. You may likely already have some in your Active Directory groups have some logic associated with how developers are aligned for access policies, and you can continue to craft those and align those with cluster group objects and workspace objects in vSphere to quickly make those connections and get developers up and running quickly with access that they need. Okay, now let's talk about cluster inspections. And so the cluster inspection service in Tanzu Mission Control will go through and run a battery of tests against a Kubernetes cluster that's attached or provisioned by Tanzu Mission Control. And it uses an open source solution called Sonobui. Sonobui was an open source solution that was originally created by VMware, and it is the conformance testing solution for Kubernetes itself. And so for any vendor distribution that wants to be a certified Kubernetes distribution. It goes through a testing through this solution called Sonobui. So the same solution here works with, is built into Tanzu Mission Control, and you can run very light, quick inspections, or you can run more complex inspections. You can automatically schedule the inspections, and these inspections really, Kubernetes does everything, via the API, and they run essentially a battery of tests against the API to make sure that the different services that are provided by the API give the appropriate responses to indicate that they're working, and may deploy workloads and things of that nature and then report back that, hey, yep, ran through all those things, all of them were working, and through Tanzu Mission Control. And then you can see there's additional customizations, enhancements you can make, such as the CIS benchmark. This is the Center for Internet Security, and so you can define the conformance inspection against these types of criteria to ensure it's not only is your environment configured according to an arbitrary standard, but if against things like CIS benchmarks, which ensure that those configurations are aligned with security, optimal security best practices and regulatory compliance standards. Okay, now we'll look at data protection. Here's an example screenshot of from TMC showing a configuration of in this instance using AWS as the storage target for the data protection. But Velero is a popular, perhaps the most popular open source solution available for doing comprehensive backup and restore functionality within Kubernetes clusters. And so Velero itself is an open source solution, it's integrated into TMC and really to be delivered as a service, as an elegant web service. Click on the tab and connect it to your storage targets, define your policy, and it's able to really back up any Kubernetes object very elegantly, restore those objects, and has the capability here of doing those on schedule or on various triggers as well. And so the data protection, backup, restore capabilities for all your Kubernetes clusters centrally provided through Tandoo Mission Control. We'll look at audit logging, and so TMC continuously collects and stores logs of audit events that describe the organization, the events that occur in your organization. And so generally, this is things including the settings that you've made within Tanzu Mission Control, and when Tanzu Mission Control applies something to a Kubernetes cluster that it manages and so on, information that's of interactions of your configurations and your monitoring events, I'll have logging associated with them, and this is available centrally through the interface that snapshot of which you can see on the screen. Okay, in summary, thank you for joining the VMware Tanzu standard course. And VMware is already the trusted provider with your critical workloads, with, again, over 80% of enterprise workloads running on VMware technology. There's no other infrastructure provider that has a base of both within, over 90% of enterprises and with, tens of thousands of IT professionals trained in operating and applying policy and providing support for infrastructure operations for enterprises. This really, Tanzu really brings the powerful, best-in-class Kubernetes and cloud-native services and pairs them with, Vsphere, the best-in-class virtualization and infrastructure as a service solution for enterprise, and brings these together and really empowering the base of infrastructure support professionals out there today to leverage their skills to really quickly bring and deliver a best-in-class Kubernetes and cloud-native service offering to IT consumers. VMware offers the complete integrated stack from management, compute, networking, storage, etc. All the things that you need to quickly get up and running and to empower an IT organization or platform provider to provide the robust freedom and wide range of services that developers and organizations need to keep pace with the cutting edge, with the controls and the protections that the centralized organizational IT platform owner needs to ensure reliability of service and regulatory compliance. And also, as organizations here seek to be able to manage the strong demand they're seeing to be able to support use cases across multiple cloud providers, yet faced with this kind of untenable complexity of having to try to go out and manually craft the policies and configurations needed to manage multi-cloud deployments. It is really kind of untenable to build and maintain at a scale that type of environment without a solution that brings together the centralized management and the ability to essentially configure and apply policy across those multi-cloud environments. And really, in summary, that's really the package and the benefits that Tanzu bring. It empowers organizations to get up and running with Kubernetes quickly on their own premise, to be able to extend that to the public cloud environment, to be able to implement robust centralized management and policy to efficiently run, operate, deploy a fleet of Kubernetes clusters and the applications to drive the next generation of business. And thank you for joining the course.